Dear students, let's see this question. He is given that a cylindrical container of radius r and height h is completely filled with liquid. Two horizontal L-shaped pipes of a small cross-sectional area are connected to the cylinder as shown in figure. So now we'll try to understand the figure. So here one cylinder is there. Here one cylinder is there. This one cylinder is there here. And the cylinder is completely filled with liquid. Completely filled with liquid here. Completely filled with liquid. And this radius is given as, diameter is given, it is 2r is given. And height of the cylinder is given as, it is h. How much height is given? Height is h. Now what we say, here two horizontal pipes are connected. So if you see how it is connected, one in this direction and the second in this direction. So try to understand, it is not upward, it is a 3D diagram, right? If the cylinder is this one, and this pipe is connected like this one. So the pipe will be this one, right? And this one will be this. That means this pipe will be outward, and for this the pipe will be inward. Clear? And he's saying that now the two pipes are open and fluids starts coming out. From here fluids is ejecting. One fluid is inward and one fluid is out. One fluid is in and one fluid is out. He's saying that the torque due to the ejected liquid on the system is. So what he's asking? He's asking that how much torque is producing, right? Producing on the system. So now you try to understand here one thing. One liquid is it is at height of, he is given that here it is given, it is an L-shaped one and small cross-section area, and it is completely here in the diagram it is given as h by 2. So here h by 2 is given, h by 2 height. Here, and this area of cross-section is small a is given. So liquid is ejecting out. That liquid ejecting out through an orifice is called velocity of efflux. We know the formula of velocity of efflux. Velocity of efflux V is equal to root 2gh. What is velocity of efflux? V is equal to root of 2gh formula. Right? So that if you understand here, height is h by 2. Height how much is given? H by 2. So through this one and through this one, both are at the same height. So the velocity ejected by the liquid through these tubes remains same. So I will write here V1 is equal to V2, which is equal to root of 2gh by 2, which is nothing but root of gh. Clear? That means with a velocity of root 2gh, with a velocity of root gh, the liquid is coming out. When the liquid is coming out, then automatically some force will be generated. Force will be generated. How the force will be generated? See, for example, here this container is there, and here some orifice is there. Orifice is nothing but a small hole, orifice. So here liquid is there. When liquid is coming in this direction, some velocity v, which is nothing but root 2gh, velocity v, which is equal to root 2gh. We already studied in lower class. When gun is there, when bullet is coming outward with some velocity v, so gun will give backward jerk, right? When bullet is coming outward with some velocity v, so gun will move backward with some velocity v, right? Conservation of momentum. In the similar manner, when the liquid is coming out with some velocity v, in this direction some force will be generated. Which will be generated? Force will be generated here in this direction. Opposite to the direction of velocity. Opposite to the direction of velocity. How much force it is? F is equal to? Can anyone tell me what is the force here? How much force it is? How much force it is? F is equal to rho a v square. F is equal to rho a v square. F is equal to rho a v square. Rho means density of the liquid. A means area of cross section of the pipe. And v is velocity. Velocity already know. So with this one we can calculate the value of F. See here I will calculate the value of F. So here force, again same velocity, then same force will be there. Here some force will be there, in this direction some force will be there, and outward also some force will be there. So here I will write F1 is equal to F2 is equal to rho a v square formula. So I will write here rho A V square. V already we know GH, root of GH. So V square will be GH. So this one, the force F1 and F2, rho A GH, right? So with this force, here it is a cylinder. One force is acting in this direction and one force is in this direction. With that force, what will happen? Then automatically torque will be generated. Torque is nothing but the turning effect produced by the body. Turning effect produced by the body. Now we are going to calculate the torque. So how to calculate? Torque can be written as torque is equal to force into perpendicular distance. Perpendicular distance here. So here torque is generated by the both, right? One is this one and one is this one. Due to these two torques, it will rotate. So the net torque acting on the body is the addition of the two torques. So here I will write then tau net can be written as due to this one how much of torque is generated, and due to this one how much of torque is generated, I have to calculate. So here force into perpendicular distance. Perpendicular distance how much is given in the question? It is h by 2. And this one is r. So here it is r. And from here it is r. So total distance is 2r. So force into 2r plus force into 2r. So here tau net can be written as 2fr. 2fr. So now we know the value of f and we will substitute and we will get the net torque. See here I will write here. So tau net can be written as force already we know. Here it is 2 into what is f here? Rho A GH. Rho A GH. So here it is here I think small changes are there. See F2R F2R. So 2 times of 2F2R, right? So it becomes 4 will come here. So here I will write here it is 4 and distance is R and I am writing here. So here tau net can be written as 4A GH into R. 4A GH into R. So here the first option is the right one. First option is the right one. Try to understand here. Torque is nothing but force into perpendicular distance. Net torque you have to calculate. Both are supporting. That's why I added force into perpendicular distance here. Force into perpendicular distance. So 2 times of this one. Again 2 into 2 here. It is there. That's why I wrote 4. So here I added. I hope you understood, right? Thank you.